Hello everyone. In this presentation, I'm going to present to you analysis of cations into groups. So first, what is cation analysis? Cation analysis is a qualitative assessment in identifying presence of your cations in your specific sample. This is done by conducting precipitation reaction which produces precipitates. Precipitation is possible due to the addition of your chemical reagents known as your group reagents. So what is the significance of this process in the pharmaceutical practice? This process is used to identify specific cations present in your drug product. So for example, if your drug preparation contains something that is toxic like mercury, lead, or arsenic, if you conduct cation analysis, you can easily identify their presence in your drug preparation, thus identifying if your drug product is safe for use or not. Now, here are the following group reagents used to classify your cations into groups. The first group reagent is hydrochloric acid. Cations that precipitate under hydrochloric acid are classified as group 1 cations. The next group reagent is hydrogen sulfide, or in our experiment, we used thioacetamide. Hydrogen sulfide precipitates cations belonging to group 2 cations. Then we have ammonium sulfide. Ammonium sulfide, on the other hand, precipitates cations belonging to group 3. The last reagent is ammonium carbonate. Ammonium carbonate forms insoluble carbonates with group 4 cations. We only have 4 reagents. Thus, if the cations did not form insoluble precipitates with the prior group reagents, it belonged to your group 5 cations, also known as your soluble group. Group 1 cation is also known as your silver group. Cations belonging to this group are silver, mercury, and lead. Group 2 cations is also known as your hydrogen sulfide group because they precipitate with the group reagent hydrogen sulfide. The group 2 cations has 2 subgroups. We have your copper subgroup and tin subgroup. These are the following cations belonging to your copper subgroup. And these are the following cations belonging to your tin subgroup. Next group of cations is your group 3 cations, or also known as your ammonium sulfide group, because they precipitate under the group reagent ammonium sulfide. Like your group 2 cations, your ammonium sulfide group or group 3 cations has 2 subgroups. We have your aluminum subgroup and your iron subgroup. These are the following elements that belong to your aluminum subgroup. And these are the following elements that belong to your iron subgroup. Your group 4 cations is also known as your alkaline earth group because elements belonging to your group 4 cations belong to your group 2A of the periodic table of the elements, also known as your alkaline earth metals. Now, here are the following cations belong to your group 4 cations. These cations form insoluble carbonates with ammonium carbonate. The last cation group, known as your soluble group, is your group 5 cations. It is also known as your alkali group because cations belonging to this group belong to your alkali metal group, or also known as your group 1A in the periodic table of elements, excluding ammonium. These cations do not form precipitates when reacted with your group reagents. Now, how does precipitation happen? Precipitation happens when one chemical reacts with another chemical to produce a product known as a salt, which is insoluble in water. In this case, we call it a precipitate. A precipitate is an insoluble solid that emerges from a liquid solution. Usually, precipitates are byproducts of chemical reactions. Now, let's dwell in the context of your solubility rule. Your solubility rule will rationalize why your cations precipitate with a specific group reagent. For your first solubility rule, all chlorides, bromides, and iodides are soluble except for salts of silver, mercury, and lead. This explains why your cations belonging to group 1 easily precipitates with your hydrochloric acid, which is the group reagent for group 1 cations. For example, hydrochloric acid reacted with the cations of group 1 will produce insoluble chlorides of lead, mercury, and silver. Again, looking back with the first solubility rule, chloride salts of mercury, silver, and lead are insoluble in water. Thus, it forms precipitates. For the second solubility rule, all sulfides are insoluble except for sulfides of ammonium and cations belonging to group 1A and group 2A. As what you can observe, elements coming from your group 5 cations belong to your group 1A cations except for ammonium, and elements from your group 4 cations belong to your group 2A cations. Thus, this is the reason why these elements or cations won't precipitate with your hydrogen sulfide group reagents, because when they react with hydrogen sulfide, their sulfides are soluble. Like for example, when you use hydrogen sulfide, which is a group 2 cation reagent, with group 1A or group 2A or ammonium, it will form a product. However, this product that they have formed is soluble. That is why there is no manifestation of precipitation. On the other hand, when you use cations belonging to group 2 cations with hydrogen sulfide, they will form insoluble sulfides. That is why manifestation of precipitates are observable with group 2 cations. This solubility rule is not only applicable for group 2 cations, but also with your group 3 cations. The only difference is that your group 3 cations will manifest precipitation under ammoniacal solutions, while your group 2 cations manifest precipitation with acidic solutions. For the third solubility rule, all metallic hydroxides are insoluble, except for ammonium, hydroxides of group 1A, hydroxides of group 2A from calcium down. This rule is applicable for group 3 cations, specifically for aluminum and chromium, because when they reacted with your group reagents, they will produce a product known as your aluminum hydroxide and chromium hydroxide. Thus, they will appear as an insoluble salt. For example, this one. In the process of analysis of cations with group 3 cations, you will use ammonium hydroxide as a reagent. Then it will react with your aluminum and your chromium, thus producing a salt that is insoluble in water. Again, hydroxides of metals are insoluble in water except for ammonium, group 1A, group 2A, and calcium down. Since aluminum and chromium hydroxide does not belong to these exemptions, then they are insoluble. Thus, they will form as precipitates. For the fourth solubility rule, phosphates and carbonates are insoluble except ammonium and group 1A compounds. This solubility rule is greatly applicable for group 4 cations. Like what I've mentioned earlier, elements in your group 4 cations are group 2A elements. Your group 2A elements is not part of the exemption of the rule. Thus, if they will form compounds of phosphate and carbonates, they will appear as insoluble salts. For example, this one. Ammonium carbonate is the group reagent for group 4 cations. Thus, when you react them with your group 4 cations, it will form insoluble carbonates because again, these are group of cations that is not part of the exemption of the rule. Thus, they will appear as precipitates. For the fifth solubility rule, salts of ammonium in group 1A are always soluble. This solubility rule is greatly applicable for your group 5 cations or also known as your soluble group, which is the reason why any type of group reagents will not form precipitates with your group 5 cations because based on our solubility rule, all salts of ammonium and other elements of your group 5 cations will not produce insoluble salts. With that in concept, your group 5 cations will not produce precipitates. Again, this is the reason why they are called the soluble group. In this presentation, I only included solubility rules that are applicable in your cation analysis. For the complete list of the solubility rules, please download it on Quipper. For the summary of points for this presentation, first we have discussed the significance of your cation analysis. Second, we have explained how does your group reagents work. Next, we have identified the different cations per group. Then, we have briefly explained how does precipitation happen. And lastly, we have rationalized your cation analysis by your solubility rule. So that's the end of our presentation. Thank you for listening and God bless.